children. Today we are going to discuss about dielectrics and its polarization. So dielectrics are non-conducting substances. It does not allow the electricity to flow through it. But when a dielectric piece is kept in an external electric field, it has an electrical behavior, and due to that electrical behavior, the molecules of that dielectric gets polarized. So let us see how does it happen. Dielectrics are normally two types, polar and non-polar dielectrics. And let us see what are non-polar and polar dielectrics. The molecules in non-polar dielectrics, they are symmetrical in nature, and they have a symmetry in it. The molecules are arranged in a symmetrical manner. The positive charge or nucleus and electron or negative charge, they are one upon another, or they are very close to each other. They are coincide each other. So therefore, they are known as non-polar molecules. So let's see the example for hydrogen molecules. So hydrogen molecules, so they are coinciding. The nucleus of the hydrogen molecules are coincide each other. Or carbon dioxide, carbon, oxygen, their nucleus, they are close to each other or one over another. But in polar dielectrics, the negative and positive charge, they are separated. So for example, water molecule, they are asymmetrical in nature, and here the hydrogen, oxygen. So the hydrogen gives one electron, so you will have a plus E, and the oxygen will have a minus E, and here also minus E and plus E. So there the nucleus of these two molecules, or these two, they are separated. So here, therefore, and due to this, there is an electric dipole moment is produced, and the direction of the dipole moment is, electric dipole moment is from the negative charge to the positive charge. Likewise, an HCl, here the hydrogen gives one electron to chlorine, so it gets negative charge, and here positive E. The E denotes the charge of one electron. So, and due to this difference in this positive and negative charges, and it acts as a electric dipole, and therefore there is an electric dipole moment is produced, and the direction of this electric dipole moment is always from the negative charge to the positive charge. Therefore, these molecules are known as polar molecules. When a polar or non-polar dielectric are kept in an external electric field, they get polarized. And how do they get polarized? First, let us see how a non-polar dielectric gets polarized. See, let us see a piece of dielectric, and here the molecule has a number of molecules. Many molecules are in it, and they are arranged in a symmetrical manner. And here negative charge, positive charge. Here the electric field, external electric field is 0 here. So due to this symmetrical arrangement of the molecules, the individual electric dipole moment of these molecules are 0. So therefore, then there is no electrical dipole moment. Then the total electric dipole moment of the dielectric is also 0. But when this dielectric piece is kept in an external electric field, so an external electric field is applied in the dielectric. So the molecules arrange themselves when a non-polar dielectric is applied or kept in an external electric field. So due to the electric field, this is the direction of the electric field. So due to the electric field, the positive charge, a force is exerted on the molecules on the dielectric. So the positive charges all will align to the direction of the electric field, and the force will act on negative charge opposite in the direction of electric field. So what will happen? All the positive charge will align to the right side of the dielectric, and all the negative charges will align to the left side of the electric dielectric. Then, so due to this, when they are aligned, the left and right side of the dielectric, so we get say that it is get polarized. Then here we can see this negative and positive charge, they aligned in the both side of the dielectric. So an electric dipole moment. So when they are arranged in such a manner, then the net electric dipole moment of this dielectric will be not equal to 0. Then that means the total net electric dipole moment is not 0 in the case when it is kept in the electric field. And the direction of the positive charges, the direction of the electric dipole moment is same as the direction of the electric field. When we take a non-polar dielectric, in a polar dielectric, the individual molecules, they are randomly distributed in the direction. So when the external field is 0 here, then the net electric dipole moment of the dielectric will be 0. Why? Because the individual molecules are randomly distributed over the dielectric. So these electric dipole moment of these individual molecules will cancel each other. So the total or the net electric dipole moment of the dielectric will be 0. But when this dielectric is kept in an external electric field, so what will happen? All these molecules will try to arrange or align in the direction of the electric field. In such a way that the direction of So a torque is produced due to the external electric field produced by applied, then all the positive charges will be, a force will act on the positive charges in the same direction of the electric field, and a force will be act on the negative charge in the direction of opposite to the direction of electric field. So the charges will arrange themselves in the positive charges in the direction of electric field and negative charges in the opposite to the direction of electric field. So we say that this dielectric is get polarized. So the net dielectric dipole moment of the dielectric will be not zero now, because it is when it is get polarized, then the electric dipole moment become not equal to zero. That means the electric dipole moment is produced here, and this direction of the electric dipole moment produced here in the direction of electric field itself. And once this dielectric get polarized, and how we can calculate the dielectric? How we can calculate the polarization of the dielectric? So we have the polarization of the dielectric is directly proportional to the electric field applied here. So we say that P is proportional to the electric field E naught applied here. So we know that if there is a proportionality constant, in order to neglect this proportionality constant, we need to multiply with a constant, and that constant is known as psi into E0. And psi is called as the electrical susceptibility of the material. And what do you mean by the electrical susceptibility? That is, electrical susceptibility is the electrical behavior of the dielectric or the dielectric material. So this electrical susceptibility is the electrical behavior of the material. So the electrical susceptibility of the different material may be different for different materials. So we can then, how we can calculate the electrical susceptibility? P is equal to psi into E0. Then how we can calculate how much this dielectric is polarized? How we can calculate the polarization of a material with respect to the electric dipole momentum? So we know that the polarization is denoted by the letter P, and that is P net divided by V, where P is the polarization, P net is the electrical dipole moment of the material divided by the total volume of the material. So this is how we can calculate the polarization of a material, and that is the here. Also we know that when the electrical susceptibility is larger for a substance, then the value for the polarization also will be large. That means P is directly proportional to the electric field applied. When the electric field applied is more, then another point, when a polar or non-polar dielectric is kept in an electrical external field, then what happens due to the external field, when these molecules are polarized, then another electric field is produced inside the dielectric. Okay, and that is due to the polarization, another electric field is produced inside the dielectric. That is denoted by EP. So here, when the strength of the external electric field is increased, so then what will happen to the external field, internal electric field produced inside the dielectric? So how we can calculate it? And the net electric field will be E is equal to E naught minus EP. So that means the net electric field, strength of the electric field will be E0, that is the external electric field minus the electric field produced by the polarization. That means if we want to decrease the electrical behavior of a substance. So what will happen? We need to increase the value of the external electric field. If we increase the external electric field, so what will happen? The internal field, electric field produced inside the dielectric also will increase, so that the net electric field, value of the net electric field will be reduced. So that's all about the dielectrics and its polarization. Thank you.